Hi everyone, welcome back to this session, and in this session we will continue with our series, and I have promised you that I will look into some miscellaneous constructs and code syntax that might be very handy and useful for you while you write in your own programs. Before then, I leave a link to my own implementation of the exercise I gave in the last session, exercise about the game, lottery game. My own implementation, I've left the link to the GitHub, which you can see it, look at the way I implemented it. I did a lot of commenting so that you can see what I did in there, so you can improve on it, you can implement it in a better way or a more efficient way. If you have any problem with it, just send me email at collabline2024@gmail.com. So for now, let's move on to those miscellaneous construct and syntax that I want to treat in this video. Let's go straight to the editor to start writing code. So first thing I want to look at is on the construct that I have been using one way or the other in some of the code that we've written so far. So that's the conversion functions, the string, integer, float, and list conversion function. These functions are used to convert one data type to another. So let's look at examples. For example, we have maybe integer variable num. If we have 36, and we can convert it to a string by saying number string, num string, let's say num string, use str and num. So this num that we have here is integer type, but the num string that we have here is a string type, and they will result in the same, looking the same. Let's print this num and let's print num string, and the only way we'll see the difference is by saying let's check type of num, and also let's check type of num string. So look at this code. We have 36, both of them will print out looking 36, but the type of num is integer, the type of num string is a string type. So if you want to say print num plus 24, this will give you 60, but let's assume we want to print num string plus 24 to raise an error which says you can only concatenate a string to a string. That means this is a string type and this is an integer. We cannot add a string to an integer. So that's it. You have seen how you can convert an integer here to a string. So the same way we can convert a float to a string, we can convert a float to a string, assuming you have a floating number. Let's call it float number 37.46, and we can have string float, which is string 37 float number. So this is true, and we can print this string float, which is just a string, and let's check the type. This looks like a float number, but it's a string. You can see the type is string. So, and this has different advantages. For example, if you want to split this into the fractional part and integer part, you can do this. Integer part, then fractional part. You use the string, which is split, and split by the decimal point. If you do this, you can print the integer part, and let's look at the fractional part also. You can see, so 37.4, you have been able to print the integer part and the fractional part. So this is a way you can split, you can use the string power to split a float number to the integer part and the fractional part. So you can see, let's say print integer part, which is our integer part. I call it inter part. So, and print the fractional part. So we can print the fractional part this way. And if we run this now, you can see the integer part is 37, the fractional part is 46. So we use the power of string method there. So also we can convert integer and floats to string. We can convert also list. Let's say my list is 1 2 3 4, and we have a list string is equal to string of my list. So if you look at this now, if you print the two, it looks the same, but one is a list and the other is a string. One is a list and the other is a string. So if you look at this, it looks the same, but if you inspect the type, you'll see that my list is a list and list string is a string type. So we can see we have a list type and a string type. You can also convert the string to an integer. Let's say we have my string, which is 1 2 3 4. We can have my integer, which is going to be integer my string. We are missing R here. Integer my string. So and now we can say is equal to my integer plus 40. Because we have converted it to string, we can add to it and print the result of new integer. So we can see this will result to 1274 now. We can inspect the type to see my string is of type, to see that my string is of type string, and my integer has become of type integer. That's obvious because now we are able to add 40 to it. So if we print this, you can see that my string is a string variable and the other one is an integer variable. We should be familiar with this. This is what we do when we say int input enter a value, and this is a string value. So this will be a string value, but after you enter it, it goes into an integer function which converts it to an integer. So if you enter a value here and I enter 234, this will change to integer and assign it to user input. So the type of user input will be integer, right? The type of user input will be integer. But if you remove this integer conversion function, whatever you enter, let's enter again. We entered 234. The type of user input will be string. The type of user input will be string. We can see now what I've been using it to convert user input from string to integer. Originally, user input from that construct is a string. So similarly, you can convert a string also to a float. So the problem with converting a string to a float or a string to an integer is that the value that you enter must be convertible to a string. For example, let's say string to integer, and we say integer, we now enter A20. This is not A20 as a string, is not convertible to an integer, and if you run this, it will throw an error. You can see the literals will not be convertible to integer. So your entry must be something that you can convert to integer. Similarly, if you want to convert string to float, so we have floats, and whatever you bring in here, it should be something that can be converted to a float. This will work correctly, but assuming you have something like this, it will throw an error because this W cannot be converted to a floating number. That's clear, I believe. So also, like we have seen, so we can convert a list to a string, and we can also convert us to a list, string to list. You can just say list, this string is A, B, C, D. So this will convert each of the character in the string into an element of your list. So let's say this, let's run this, and if I say print string to list, let's say the second element of our list, what should we expect here is B, because this is the second element of our list. If we print this, it will be B. So this has been converted to a list for us. You can iterate to the in the list. Let's say for character in range length of the list, for character in range length of the list, right? We want to print each character, which is this, and we have printed the ABC. Assuming you want to print it without, as in on the same line, we have it ABCD like that, and you don't want a space within them, you can print it this way. So, and that is conversion of string to list. So another thing that I want to show you as an example of using conversion, let's say we want to write a code that iterates from 1 to 10,000 and print out palindromic numbers. Palindromic number is one that reads the same way backward and forward. So we can say for I in range 1 to 10,000, we want to convert each of these to a string. We want to convert each number to a string, and we want to see if this string is equal to when the string is read from back to forward. So the construct, this is reading S back to forward. So this, the first one converts all the number to string, and now reads the number from back to forward and compare it with reading the number in correct way. So if you run this, we say print S. If this is true, print S for all numbers from 1 to 10,000. If you run this, you can see 1 reads, all the single number reads the same way from back to forward, of course. So you can see 11 reads the same way from back to forward, 22, 44, 55. You can see all the numbers here reads the same way. As you read it from front to back, that's how it reads from back to front. You can see the power of converting numbers to string. Here we convert the, which is a number, to string, which becomes S, and now we can use the string construct of reading from back to forward to check if is a palindromic number. Another example that I want to show you here now is let's say we ask a user to enter, we have a user's birthday which says June 16, 1979. That's the birthday. So we want to extract the year from the birthday. You can see the extraction is the last 4 number, so we can say extract the year from this and make it, convert it to an integer. So extract the year from the birthday. Let's first extract the year in string so that you will understand. Extract the year in string from birthday, and that will be the last 4 character, the last 4 character in the string. That is the construct to extract the last 4 character. Then we now say the year of birthday is integer year in string, so we convert the year that we have extracted in string to an integer. So now I want to use this import date time. So this imports a module called date time, and we can now get current year that we are in now, which is data dot date time dot now, and we extract the year from it. So this extracts the year from the date, the current day we are, and we want to see what's the difference between this current year and the year that the user was born, so that we know the age of the user. We can say print you are, so current year minus birth year, so years old, right? So the user have entered is birth of year in string, and we extract the last 4 digits, which is the year itself, and we convert that year to string. We import a date time module, and from that date time module we get the current date and the year. We extract the year out of it, then we use this to get the year age of the user. If I run this, you can see someone born in 1979 is now 45 years old. Let me say it is 1999, then the person is 25 years old. If it is 1953, the person should be 71 years old. So that is another example of using this conversion construct in your code. So let's see another example. So let's look at this example that takes a number and adds its digits. Now it takes a number, when you have a number, let's say is equal to 435, and we can convert the number to string, which is a string number, and we can start by addition, which is equal to 0, addition of digit addition, let's call it digit addition, which is equal to 0, and we iterate through the string. Let me bring it up. You know that we can say for character in number to string. So for character in this number to string, we can say digit addition, so is equal to, you add this to that character converted to integer back. So you can say this is equal to the final result. Let's print it out outside the for loop. So for this, it should be 3 plus 4 plus 5, which is 7, which is going to be equals to 12, and we can see the result is correct. So what we did here is similar to saying addition, digit addition is equal to this number to string. You know, we can get the index, the first one. So the number to string is let's say we have integer numbers to string, the first character to string, then you add it to converting the second character to string, and add it to converting the third character to a string. If you run this and we print digital add 2, we should get the 12 back. So that's what we've done here. So similarly, what we have just done, we can use list comprehension to do it. We can use list comprehension to do this digit addition that we have just done. Let's say digit add 3 is equal to sum, right? Sum can be used for a list. You can sum whatever is inside a list. So we want to generate that list. The list is conversion of n to an integer. This n will be converted to an integer for all n that is in this string that we have converted, this number that we have converted to string. So this is a list of all the character that is here, which is 345, which we have converted to string, and we have now convert all that character back to string. We now sum it up. So if you print this digit add 3, it should give us the same 12. What we did here is just that we created a list that has this 3, 4 and 5. we created a list that has this 3, 4 and 5, and let's say add 3, let's call it add 4. We now set sum of that list. So sum of the list will sum up every value inside the list, and it will give us the same thing that we have been looking at, which is 12. So if you look at this, it's 12. So yes, that's an example. Let's look at another example that will generate something that I want to quickly mention. That will generate something I want to. As we have a float number that is 34.28. So 34.28. Let's say we have the integer part. So initially I did this by converting to a string, then I split it with a string. But now I want to do it in another way. The integer part, by converting the float to integer, we say integer float number. So what this does is that it truncates all the decimal parts. You have converted it to integer, it truncates this away for us. And if you look at this value, print integer part, this will give us 34. So it truncates the decimal part. Now how do we get the decimal part again? We now get the fractional part by saying float the original number minus the integer part. So if you look at this, we can say print integer part, which is now I part, and I can also print the fractional part, which is now F part. So if I run this now, this is what I want to actually show. So you can see this is 34. We're supposed to get this 0.28, but we have this. So this is a problem with Python floating number precision. So you should be careful when you are writing floating codes that use float number. So with this, you can see in Python, floating numbers are represented using binary floating point, which inherently produces some limitations due to the finite precision of binary representation. This limitation can cause inaccuracies, often referred to as floating point rounding errors. Or floating point imprecision. Here are some common reasons for imprecision in floating point number in Python. So there are you can read through the documentation of Python with floating points here. So this documentation, let's look at this. So floating point arithmetic issue, you can read through this in this site to see the issue with representing in float in Python. So you can see that we expect 0.28 here, but it gives us this imprecise number. How do we now solve this kind of issue? So a way you can do it is to use this decimal module. Let's say from decimal import decimal get context. So I imported two method here. So initially this will set the precision to 2 decimal places. So we can say get context dot precision is equal to 2, and now we can define your floating point number as float num is equal to decimal 34.28, right? So 34.28. Then we can now say perform calculation with the specified precision. So the specified precision, now we can say I part integer part integer part now equals integer float num. So that will truncate this 0.28, and we can say fractional part now is equal to float num, okay, minus integer part, and we can now print our integer part now equals to I part, and print the fractional part equals to part. So if we run this, you can see that we have a precise value. We have a precise value which is 34 then 0.28. So you can see how this works well for us. And another thing that I want to show you, which I have been using, is the shortcuts which I have always been using in the codes one way or the other. For example, if we have count 14, we can this is just a variable that we assign 14 to count, and we can add 1 to count by saying count is equal to count plus 1. Short form of this is to have count plus equals to 1. This means the same thing as this. Also, we can do the subtraction of this short form, we can do the multiplication of this short form, we can do the division of this short form, and this is another operator, and the operator divides the current value, which is count, by 3. Sorry, this is by 5. Divide the correct value by 5 and assign the quotient to count. So it only takes the quotient, it leaves the fractional part. It's just like we have done with this floating point, which actually truncates the quotient of this 34.28. so this only assign the quotient to the integer part. So the same thing this will do, it divides by 5, and if there is any fractional part remaining, it truncates it. It only assign the quotient to the count, and this modulo is assigned the remainder of the division to count. So whatever you divide, if count is 5, so it divides count by 2, which remainder will be 3, and that remainder is what is assigned to count. So if we run this code now, we'll see how this works. So the initial value of count is 14. Count is added by 1 is added to count, which makes it 15. 15 now, 1 is added to count again, which makes it 16 with this shorthand form, and 1 is taken away from count, which makes it 15 with this shorthand form. Count is multiplied by 5, which is 15 times 5, which is 75, and count is divided by 2, which gives us 37.5. count is divided by 5, and now the quotient is assigned to count. So that's 7.5. Let's look at a calculator. 37 divided by 5 gives us what? 7.5. so it takes away this 0.5 and assign the remainder to count, so it has only 7. So count now is modulo 2, means that count is equal to count as modulo 2. This means count is equal to count modulo 2. So count modulo 2 is 7 modulo 2, which gives us remainder 1. So that remainder 1 is assigned to count, and the final value of count is 1. You can see how that shorthand form works. I have always been using this. Other thing, you can say A is equal to B is equal to C and is equal to 3. All this is the same as saying A is equal to 3, B is equal to 3, and C is equal to 3. Now we can also do something with list, something similar with list. Let's say we have a list L, which is equal to 4, 5, and 7. So we can say X YZ is equal to L. So if we have a list L of 457, we can say this is equal to L, XYZ is equal to L. So it's the first element of L is assigned to X, second element of L is assigned to Z, and the third element is that if you print X, what we should expect is 4, and if you check what is inside Z, let's say print Z, the expectation should be 6. So another thing I quickly want to mention is the concept of short circuiting, and this is clear if you are, for example, we have list of words. So if we have list of words, these are our list of words, and we want to test for every value in this list of words, we want to print out anyone that has R in as its third element. Let's say for word in list of words, we want to have words, if the word has in its fourth element is equal to R, then we want to, if the word third element is equal to R, we want to print the words out. We want to print the word that has its third element, its fourth element equals to R, like Marrow has its fourth element equals to R, the same thing. So if you look at it, will work, but it will throw us an error here. Why? Because it's testing for the fourth character of the words, but mom does not have a fourth character. It's testing for an index that doesn't exist in this case. So how do we get this? So let's comment this out. A way we can do this is to say, if for test, if the length gets to 5, if the length is greater than 4, that is when you can now test, and if the third element is equal to R. So in this case, we have tested if the length is greater than 4 and if the third element is equal to R. We will be wondering that since we still test this, if the fourth element is equal to R, it should give us an error, but no, it will not give us an error here. It will print those ones. What happens here is that if this test is false and we have an AND element, the testing of the second one will not be done again. So it is short-circuited. Since this is false, then it knows that the output of an AND operation will be false, so it doesn't do this again. So the error with mom will be short-circuited here. The error with mom will be short-circuited. Only those that has words greater than 4, that the second one will be tested. So another thing is another construct which looks very useless is let's say we have this list of word. Let's say we have if mom list of word pass. It means if mom is in list of word, do nothing. You'll be wondering what is the reason for this. Sometimes in your coding you might need such construct. If you know that it exists, when you need it, then you know how to use it. So this says if mom is in the list of what, do nothing. Another thing I will quickly show you is string formatting. So string formatting, let's imagine sometimes you want to have item cost in your code. Item cost is equal to 14.50, and we have total cost, maybe they bought 5 items, so that will be item cost multiplied by 5. And if you want to print, assuming you want to print total cost of item bought is this, and you print this, you see that cost is 72.5. You will want to print the money value in, let's say, 72.5 or 72 pounds 50 pence. That's how you will want to print it, and that is where the formatting comes in. Let's say we have total cost is, so we have pounds in front now, and we can say this total cost for this is to choose. Then we have the formatting, format total costs, right? So this gives us a way to format this in the monetary form. You can see now that we have total cost in a way that money value is being displayed. So this is an example of ways you can format. If you put 3, it will give us 72.500. So we want it this way, to decimal places. So this is a formatting option for you. You can look up other format ways you can format strings. For example, this way you can see it formats them in right alignment. Is that right alignment? Yes, right alignment. So, and if you want it in left alignment, you can just put this, this, and this, and if you run this, you have the left alignment. And for example, you can also do it in, how do I call this, middle alignment. Is there anything like middle alignment? If you run this now, you have, okay, let's make it, to make this look clearer, let me put it to 5 digit places. So let's have numbers like 2, the 3, and 34. So this will give us a good look of that alignment. So you can check more about formatting options that we have in this documentation of Python, input and output formatting. You get used to it. Try some of this formatting in a fancier output and see what you have. There is a construct that I did that prints the times table, 12 times table, in a way. So I have this for loop from 1 to 13, and another inner for loop from 1 to 13, and we print the multiplication of the first element of the for loop range and second element, which gives us this output, and this is 2 times 1, 2 times 2 times 3 times 1, 2. So this design does not represent exactly what the formatting element is, but I have another way. I did it in another way, which I will give you as an exercise, which displays this in the correct form that I would love. This is here. So this display is more like what we have in times table. 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4. Then we can say do it this way: 2 times 2 4, 2 times 3 6. This is more correct. I want you to write the code. This has been written somewhere. I just pick the picture here for you. The code is not here. I want you to write the code as an exercise to give this format. The one I have here gives this output, which is not totally as correct as what I want. This is the correct way. If you can write the code that can give us the correct output of 12 multiply 12 times table like this, it will be interesting. I'll give a link to the exercise, the answer to the exercise, in the next video. For now, let us pause on the miscellaneous concepts that we have been exploring. You may want to explore deeper by looking at Python documentation of these constructs, Python documentation on list, Python documentation on strings, Python documentation on formatting. You can look at this and see what exists therein and how you can apply them in your program. If you know the, you will recall when they are at the point of your writing program to solve a problem. You will recall if there's something you can use that you have seen before. So in the next session, we'll be exploring another very important construct in Python, that is a dictionary. So it's another data structure that stores data in key and value pairs, and it is very versatile and efficient way to store data and retrieve data in your Python program. I will explore next this data structure, and we'll learn how to define dictionary, how to manipulate and use it in your program.